Right.
Now we're looking at Aleks 1, 2. Whoops, lesson 1, 2, number 7. So let's take a look at this. It says again, find the domain and range of a graph of a quadratic function. A quadratic function just means it's going to look like a parabola. It comes from the equation where your highest power is squared on x. So y equals x squared is an example of something quadratic. It says the graph of a quadratic function has with a vertex of 2, 4. So the x is 2, so the y is 4. That's what that point is. The vertex is shown in the figure. Find the domain and range. And so as shown on the previous video, what we can do here is smash the x-axis, smash the y-axis using crash compactor technique to get our answer. So if you just envision, whoops, I'm doing range. I'm not supposed to do range first. Let's get that out of there. We'll do domain first. So if you imagine, no, I had that right. What am I talking about? We're going to the x-axis first. Let's get my life together here. Domain and go to the x-axis. So you'd smash everything to the x-axis first to find the domain. And so they didn't name this graph, but what I'm going to do when I smash the x is imagine this point goes smashed there. This arrow gets smashed straight down, but now it's pointing, because it was pointing up and to the right, I take away up. I'm not paying attention to up and down anymore. Everything gets smashed flat. So I'm just going to point it right. It's connected by a solid curve. I'm going to connect it by a solid line. And over here, arrow falls. It's connected by a solid curve. I'm going to connect it by a solid line because we flattened it out. We just smashed it all in. This means the graph's going to go left forever and right forever. So we'd have a negative infinity followed by a positive infinity. Now, is infinity a real number that it can be equal to, or is it like more like an idea, a representation of something?
An idea, it can't be equaled.
That's right. It's an idea. It just means forever. It's an idea of something going on forever. So for that reason, it gets parentheses. So that was the domain.
Okay, but what about the 2?
Okay, so the 2 doesn't matter. I put it as a closed dot. Originally, it was just a solid curve. And so a solid curve is like solid points. So technically, this is like solid points all through here. If you ever need to find a point, they're solid because the curve is solid. And so I just added that point to represent the vertex of 2, 4. That's why I put the point on there.
Okay, so that would be the domain. That's it, just negative infinity and infinity?
That's right, because the domain doesn't break in there. It was a solid dot, so it just continues on past it. Anything solid, it just continues on without stopping.
What if it, instead of a solid dot, it was like a circle dot? Then it would be negative infinity 2 parentheses?
You got it. So if we had that open circle there, this graph would look different. We would have this. And so now our domain, if that were the case, we go from negative infinity to 2, union with and you'll have a circle, or I'm sorry, a parentheses, because you're not equal to it, it's an open circle, and then you do a union. Anytime you have a break and have a second piece, you do a union, and then you'd pick back up from 2 going to infinity. It would look like that.
Okay, that makes more sense.
That's how an open circle would look. Now, that wasn't a part of the problem, so I'm going to erase this so we're not confused. And erase that. Now, we've done domain, so now let's jump down to range. So I'm going to just ask you right now, do you think the range is going to be all reals like this? By the way, this could be called all reals. X, E, with that double looking R, you could write it this way. So you could write your answer either format. You could write it like this. This is interval, or this. This is typically a symbol for inequalities, but you could write it either way there. So now let's look at range. Do you think it's going to be all reals?
No, because it has a vertex.
That's right.
Like the bottom point. Only one of them, one side would be infinity.
You got it. So I'm going to smash there where we can see the y-axis numbers. Smash this across to the y-axis. And so now, this point here, let's do it. I did it black last time. Let's do it black again. Okay. There's the vertex smashed straight over. Here are the arrows smashed straight over. They're connected by solid curves. I'm going to make it a solid line since I'm flattening it out. And so this is now the range of the graph right here. The lowest point is 4, the highest point is infinity. So it's going to go from 4 to infinity. As we talked about, infinities are always parentheses. 4.
Be a bracket.
You got it. Now, because this doesn't tell you, oh, it does say it right here, the right interval notation. For that reason, I shouldn't be using this. But if it was an inequality, you would then write this as 4 is less than or equal to y. That's how you'd write that one. If it was an inequality.
Okay.
It's not. So I'll erase it so we're not confused.